Trig. Lesson 68 is kind of long because there are 3 different parts. So first we're going to start with 68.A. And 68.A is to give us a different definition of what a parabola is and introduce us to 2 new terms. So before we start, let's go over some principles about a parabola. A parabola is the graph of a quadratic, and it is a perfect U shape. So 0, 0, 1 squared is 1, 2 squared is 4, and parabolas are symmetrical, meaning the right-hand side should be perfectly symmetrical with the left. And so there is a standard parabola. Now, the number in front of x squared determines how wide, how skinny, whether it points up or down. So a fraction, the effect of a fraction is to actually widen a parabola. So instead of going over 1 and up 1, it's going over 1 and up 1/3. If I went over 3, I'd go up 1. And so the effect of a fraction is it greatly widens our parabola. The effect of a constant out front makes it more narrow. So instead of going, if I had 0, 0, if I went up 1, 1 squared is 1, but 1 times 3 is 3. And so a number greater than 1 makes it narrow or stretches it vertically, versus a fraction compresses it, making it more wide. Now, if it is negative, that effect is to then flip it upside down. It doesn't change the value of A, but it causes it to have a vertical reflection. Okay, so those are the effects of the number out front. Just a review. Now, this section defines a parabola using new terms. So a parabola is the locus of all points that are equidistant from a given point called the focus and a given line called the directrix. And I've drawn a picture here with both a focus and a directrix. A directrix is this invisible line underneath or above. It's on the outside of the parabola. And your focus is a point on the inside. Think of this as a real-life example. Think of this as the satellite. Not many people have satellite cable, but think of it as a satellite on your house. And I don't know if you've noticed a satellite there's usually a ball out front, and it should be the same distance, equal distance from any point on the parabola and any point to the roof. So if that helps. So the distance from this point to the outside of the parabola should be equidistant from the outside to the directrix. And that's why I marked it with a single tick mark. Like in geometry, that signifies congruency. So let's go over standard form or vertex form of a parabola is a times x minus h squared plus k. We call this vertex form because the vertex is at h comma k. Now, where does p come into place? Well, the value of a is equal to 1 divided by 4 times p. And in that case, your focus will be at 0p, and our directrix, whoops, I left an I out, will be at y equals negative p, or the opposite of whatever you got. And so this is the new piece of information right here, and we're going to do some examples including that piece of information. So number 1, we are going to find the focus, the directrix, I keep leaving out that I, and we will graph y equals 2x squared. So the first thing I'm going to do, I'm actually going to graph this. That's the first thing I'm going to do. So here's x, here's y. And I'm going to change my scale 1 2 so you can see it more clearly. Just so that it might help. You don't have to change your scale, but I'm going to. So I'm going to graph it first because I know that the vertex is at 0, 0. And I know that A is 2. So if I go to the right 1 squared is 1 times 2 would be 2. I wonder why I graphed it the way I did. Huh. And then if I went up to the right 2 squared is 4, 4 times 2 is 8. So I don't have room for that point given the scale I used. And then I'm going to find the value of P. So I know that in mine A equals 2. And they told me here A is equal, so this is equal to 1 over 4P. So in order to solve that, I'm going to solve for P, right? And so to solve, I'm going to actually cross multiply. So 2 is over an invisible 1, so 1 equals 8P. So if I divide by 8, P equals 1/8. So right here I cross multiply. Okay. So if P equals 1/8, then I know my focus is at 0, whatever P is, so 0, 1/8. 1/8, if you prefer a decimal, I believe is 0.125. Yep. And my directrix will be at y equals a negative 1/8 according to my formula. It's the opposite. So I'm going to, negative 1/8 would be right below, right? It would be, so I have an invisible directrix at negative 1/8. And I have a focus really right above the vertex. And so that would be it. Number 2, I am going to do another one just so you have more practice because it does give us more complicated formulas later. So sorry, I'm going to turn my page in my notes. So the next one we're going to do the same. We're going to find all of that. We're going to find our focus, directrix, and graph. Y equals negative 3/7 x squared. So I'm going to graph it first. Now I recognize right away that that negative means it's going to be flipped over. And 3/7 is an odd fraction. So I'm actually going to build a table. I'm going to keep my scale by 1s. This time I'm not going to change it. And I'm going to build a small table because of the odd fraction I have. So I'm going to just build a couple points. I know my vertex is at 0, so I'm just going to plug in a couple points, and then I will reflect it. And so if I plug in 0, I'm going to get 0, right? Because anything times 0. So negative 3 divided by 7 times 1 squared is negative 0.43. And then I'm going to just use my arrow key to change this to a 2. Whoops, let's try that again. This should be changed to a 2. And I got negative 1.7, and then I'm going to try one more. Negative 3.9. So I'm going to graph those points. So I have 0, 0, negative 0.43, 1.7, 2.9. And then I am simply, it doesn't seem right. Oh, yeah, no wonder. This is 3.9. I put it at 2.9. And then I'm going to reflect these points across. So that would go here, here, here. Okay, so there is my parabola. Now I'll work on finding the focus and directrix. So I know that A equals 1 over 4p. My A value is -3/7, and that should equal 1 over 4p. And I'm going to cross multiply. I think that's the easiest way. So I get -12p equals 7. And so I'm going to divide by the -12. And p equals -7/12. And so my focus is going to be at 0, -7/12. And I'm going to make that a decimal. So -7 divided by 12, it's going to be a little over 1/2. So I'm going to graph that as 0 and -0.6. So 0 and -0.6. So there's my focus. The directrix will be the opposite value, so y equals a +0.6. Sorry, +0.6. So that would put us a little above 0.5. We're just predicting. And so there it is. All right, so last one. I'm going to give you the information just so you have this practice. So if the focus is 0 and -5/3, and the vertex is at the origin, find our equation, and graph. All right, so let's talk about where our focus is. And we'll go from there. And I should probably make this a little bigger. So if our focus is at 0 and -5/3, then they're telling us that the value of p is -5/3, which equals -1.67. So that means my directrix is at y equals +1.67. So let's start with that picture. That might help everyone understand where everything is. I'm not going to change my scale. Okay, so I have a directrix at +1.67. And I have a focus, right? Whoops, I should have written that. So my focus, and they already told me, is right here. So I have a focus at -1.67. So I know that that little ball, or that focus, should be inside my parabola. So my parabola points down. And so we're going to write our equation. A equals 1 over 4p, and they told me what p is. So I'm going to replace that. So A equals 1 over 4 times -5/3. Okay, so that gives me 1 over -20/3, which is 1 divided by -20/3, which would be 1 times -3/20. So that would give me -3 over 20. So my equation is -3 over 20x squared. So I hope you can see that. So I have my equation. Now I'm going to write my graph, and I'm simply, like I did earlier, I'm going to build a table. And so I know it said the vertex is at the origin. Origin is at 0, 0. So now I'm going to build a table with just a few points. I know the vertex, I'm going to pick 1, 2, 3, just like I did earlier. So I have -3 divided by 20 times x squared. So 0.15. So I'm going to make that at 0.2 and reflect that across. Let's try plugging in 2, positive 2. And I get negative 0.6. So this next point I'm going to put here, and I'm going to reflect that across. And let's try 3 squared. Negative 1.4. So at 3, it's negative 1.4, and I'm going to reflect that across. So, whoops. You can use Desmos for the shape of the graph. All right, so I am going to move on to 68 point B. And I am going to actually write on the back. So 68 point B is on translated parabolas. Whoops. And translated parabolas are in vertex form, but instead of writing A, I'm going to write 1 over 4p times x minus h squared plus k. And so know that our vertex will be at h comma k. Your focus will be at h comma k plus p. Your directrix will be at y equals k minus p, and your axis of symmetry is x equals h. But honestly, you guys, you can use Desmos, do the graph, but you'll have to find the focus and directrix by hand. So let's do number 1. We are going to, where's the problem? If my vertex is at negative 2 and 1, and my focus is at negative 2 minus 1, write the equation and graph, find your directrix and axis of symmetry. So that is all that they'd like us to do. So let's start with our vertex is negative 2, 1. So I know h equals negative 2, and I know k equals 1. They're also telling me what my focus is. And so I know that my focus is h comma k plus p. So I know h is negative 2. I'm going to plug that in. And I know k is 1, so 1 plus p. So you're telling me that 1 plus p equals a negative 1 because they've told me where the focus is. So if I subtract, I know p is negative 2. And so I'm going to plug that into our equation based on what I have. Y equals 1 over 4 times negative 2 times x minus h, which is negative 2, squared, plus k, which is a 1. And we're going to simplify that. So my equation is y equals negative 1/8 x plus 2 squared plus 1. And that fits. If h is negative 2, then it's positive here. If k is 1. So this is my equation. Now, using Desmos, you can graph this, right? You don't need me. But I am going to do it by hand. And you can see how I do that. All right, so let's start with my vertex is at negative 2, 1. My focus is at negative 2, negative 1. So here's my focus, which if this is 2 units away, then I know that my directrix is also 2 units away. So that would put my directrix at y equals 3 because this should be equal distance. They also told us our directrix is y equals k minus p, and we know our k value is 1, and our p is 2, so it's at 3. So y equals 3. Sorry, let me unlock my screen because this section is longer. It's more than 20 minutes, so that's why it cuts us off. So I'm going to build our graph from this point. So I'm going to do it by hand. You can use Desmos. If x is 1, 1 squared is 1. But I have to multiply that by a negative 1/8, so I'm only going to go down negative 1/8. So I'm going to try, what if x is 4? So if I go over 4. 4 squared is 16. 16 over 8 is 2. So I went down 2. And so I'm going to reflect that across and reflect this point across, and I bet those are the same points Desmos will give you. So there's my graph. Just doing it by hand. I know, amazing, right? And we are going to move on and do one more, and then we'll move on to part C. Told you this one's long. I say first, for number 2, our vertex is at 3, 4. Our focus is at 3, 4.5. They'd like us to find O. And I didn't hear earlier, sorry, but our axis of symmetry would be right through our vertex. So our AOS is x equals negative 2. All right, number 2. So here is our vertex and our focus. They'd like us to graph. That's all they're going to give us, and so we're going to find everything else. So I know that h is 3, k equals 4. I know that if our focus is at 4.5, then I know that p equals 0.5 because that's the change, right? And so if p is 0.5, then I know I can find my formula. So y equals 1 over 4 times p, x minus h squared plus k, and simplify that, 1 over 2, x minus 3 squared plus 4. So there's our equation. If our focus is at 4.5, then our directrix should be in the opposite direction. So that would put it at 3.5. So because you're going behind the vertex, if it helps, graph what you know so far. So I know 2, 4, 6. 2, 4, 6. So my vertex is at 3, 4. My focus is at 4.5, so that means the directrix should be the equal distance behind it. You can use Desmos to graph, but I'm just going to use, I'm graphing by hand knowing this. But I'm starting where I'm at. So 1 squared is 1, but it's being cut in half, so 0.5. 2 squared is 4, but it's being cut in half. And so I'm going to reflect those points across and there. But you can use Desmos and then just find the directrix and your focus. All right, so I'm sure you want to move on if you're even watching this. So 68 point C is applications, like how to apply this. And earlier I said to think about focus and directrix as like the satellite for cable TV, the satellite they attach to your house. So if a parabolic antenna has the shape of I should write the whole equation, of y equals 1/20 x squared. If the measurements are in feet, how far from the vertex should the receiver be placed if it is to be at its focus? Whew. So you have this parabolic antenna. They're asking how far away should the receiver be if it's its focus. So how far away in feet? So I know that A equals 1 over 4P, and they've told me we have 1 over 20, so P equals 5, so 5 feet. That's it. And that's how they all are, so I'm only going to do one. In 68.D, we are skipping the homework for 68. You can skip numbers 5, 6, 12, 18, 19, and 29. Whoa, that's a weird 9. And that's it.